Machine learning. I know it sounds super complex, right? But what if I told you it's really just about teaching a computer to learn things, pretty much like we do? In this explainer, we're going to break it all down by looking at the three main ways a machine can learn. So let's dive right in.
To get us started, let's just ask a simple question. How would you teach a robot to see? And I mean really see. How would you get it to recognize something specific, like, say, your pet dog?
Well, you'd probably do it just like you'd teach a little kid. You'd show it thousands, maybe millions of pictures of dogs, big dogs, small dogs, fluffy dogs, all different kinds. And eventually, after seeing all those examples, it just starts to get it. It picks up on the patterns and can spot a dog it's never even seen before. And that, in a nutshell, is the core idea of machine learning.
So here's the really important part. We aren't writing code for every single possible scenario. No way. Instead, we're building systems that learn for themselves directly from the data we give them. It's this powerful piece of AI that lets a machine make its own decisions based on everything it's learned.
But this is where it gets really, really interesting. Just like people have different ways of learning, so do machines. It's not a one-size-fits-all kind of deal. The way you teach it depends entirely on what you're trying to do. And there are three main styles, which we're going to walk through right now.
First up, we have what's called supervised learning. And honestly, the easiest way to think about this one is to just imagine the machine has a teacher helping it along.
In this case, you are the teacher. You give the robot a picture, and you also give it the answer. You show it an image and you label it, saying, "See this? This is a cat." Then you show it another one, and this is a dog. The machine learns from all these clear, pre-labeled examples you give it.
So that brings us to the more official definition. In supervised learning, the data is all neatly labeled. The algorithm's entire job is to figure out the connection between the picture it sees and the label it's been given. The big challenge here, though, is that getting all that high-quality, labeled data can take a ton of time and, be pretty expensive.
And this isn't just some abstract theory, it's literally everywhere. Your email's spam filter? It learned to tell junk from real mail by looking at millions of emails that were already labeled spam or not spam. The facial recognition that unlocks your phone, your voice assistant, they all depend on being trained with tons of labeled data.
Okay, so what happens when you take the teacher out of the room? Well, that brings us right to our second style, unsupervised learning. This time, you give the robot that exact same pile of animal pictures, but there's a huge twist. No labels. You don't tell it what's a cat or a dog or anything else. You just hand over the messy pile of data and basically say, go for it. See what you can figure out.
So with absolutely no guidance, the machine starts sorting things. It might not know the word cat, but it starts to notice that a whole bunch of these pictures have pointy ears and whiskers, and it groups them together. It uncovers these hidden structures in the data all by itself. Sometimes what it finds is a bit of a black box. We can see the pattern it found, but we don't always know exactly why it decided to group things that way.
This slide just lays out the difference perfectly. With supervised learning, you have labeled data, and you know what the output should be. But with unsupervised learning, you start with this big, unlabeled jumble of stuff, and the machine has to find the order on its own. It's kind of like the difference between studying for a test with an answer key and being a detective trying to solve a mystery from scratch.
And you see this one all the time too. When a streaming service recommends a movie you might like, that's because an unsupervised algorithm noticed that other people who watched what you watched also liked that movie. It's just finding patterns in our behavior to make a really smart guess.
Okay, we've covered learning with a teacher and learning all on its own. Our third type is a whole different ballgame. It's called reinforcement learning, and it is all about learning from good old-fashioned trial and error. The absolute best way to think about this is like training a dog. When your dog finally does the trick right, you give it a treat. That's a positive reward. And when it doesn't, it gets nothing. Over time, it learns which actions get it that awesome reward. So in the machine learning world, the dog is what we call an agent. You can think of it as the AI player or the program. And the world it's in is the environment. That could be a video game, a chessboard, or even the streets of a city for a self-driving car. The agent tries an action, and based on what happens, it gets a reward or a penalty. Its entire goal is just to figure out the strategy that gets it the most rewards possible. This creates this amazing feedback loop. The agent tries something, sees what happens, and then tweaks its strategy based on that outcome. It's just a constant cycle of try, fail, learn, and try again, but millions of times a second. And this method is behind some of the most mind-blowing achievements in AI. I mean, when Google's AlphaGo beat the world's best Go player, it wasn't because it was taught every possible move. Nope. It learned by playing millions and millions of games against itself,
constantly getting better through this exact reward system. So cool.
So there you have it, our 3 mean styles of learning. Now let's just pull it all together and see how these things pop up in your life pretty much every single day. Okay, here's the perfect little cheat sheet. Supervised learning. That's learning from labeled examples, like your spam filter. Unsupervised learning, it's all about finding patterns on its own, like those movie recommendations you get. And reinforcement learning, learning from rewards and punishments, like those crazy smart AIs that can master complex games. 3 totally different approaches for 3 totally different kinds of problems. Ultimately, the big thing to remember is that this technology isn't science fiction anymore. It's a real, fundamental part of our world, and it's working quietly in the background all the time to make things just a little bit easier, a little bit safer, and a little more connected.
And all of this leaves us with one last, really fascinating question to think about. We've spent all this time focused on how we can teach machines, but as they get better and better at learning and finding patterns that we might never see, the real question might become, what are they going to teach us?